A renowned Nobel laureate warns us that the James Webb Telescope has just discovered something strange in the universe, and we may not even be ready for the changes that are coming. The latest discoveries pose serious problems for our science. It's getting crazier and crazier because, yet again, James Webb has discovered a completely new phenomenon that is turning our physics textbooks upside down. Astrophysicist and Nobel Prize winner Adam Rees has long suspected that the scientific community is heading for disaster. Researchers report piles of unsolved puzzles that are growing every day. Can we still get to grips with the situation, or is our science at an end? Adam Rees is probably one of the few researchers who is keeping a cool head these days. Since the launch of the James Webb Space Telescope, nothing is as it used to be. The universe is probably much older than assumed. Galaxies have formed much faster and quite differently than all our predictions, and our cosmos may not be expanding from a single point. What happens now if dark matter is possibly still a mistake, and James Webb is already presenting the next picture of inexplicable phenomena in the cosmos? Adam Rees is one of the leading experts in the field of research into the expanding universe. His contribution to the discovery of the accelerating expansion of the universe revolutionized our view of the cosmos and was one of the cornerstones of the Hubble excitement. Rees welcomes the telescope's latest discoveries because he knows from his own decades of dedicated work that our cosmology is flawed. He was involved in surveying the cosmos and using supernovae as standard candles for the first time. In this context, standard candles are something like cosmic scales that scientists use to measure movements and distances in the universe. Using supernovae as a yardstick, astonishingly precise measurement results could be achieved. But one problem remained. Rees and his team found that the expansion of the universe was increasing regionally instead of decreasing. In the course of their work, another phenomenon became apparent as Rees's measurement results differed significantly from those based on the redshift method. This should not really be the case. Today, we know the differences in the measurement results as the Hubble tension. Rees's work was so phenomenal that he was awarded a Nobel Prize in Physics in 2011, together with his colleagues Saul Perlmutter and Brian P. Schmidt. In fact, he received the award for the discovery of the accelerated expansion of the universe. Rees and Schmidt are members of the High-Z supernova search team, which is researching techniques to refine the measures of distance in the universe. Perlmutter, on the other hand, came to the same conclusions at around the same time as part of the supernova cosmology project. They observed type Ia supernovae, very bright exploding stars that serve as reliable indicators of distances in the universe. These observations provided surprising evidence that the rate of expansion of the universe is increasing rather than decreasing due to the gravitational effects of matter in the universe, as previously thought. The biggest crisis in modern science was slowly brewing, and now the bomb has exploded. Instead of answers, astronomers and cosmologists are constantly being served up new puzzles and shocks these days. Now, the concept of an isotropic universe is also on the brink of collapse, and with it, one of the fundamental pillars of our cosmology. Isotropy assumes that the universe looks the same in all directions, regardless of where you look at it from. This assumption is a fundamental part of the cosmological principle, which states that the universe is homogeneous and isotropic if we look at it on a large enough scale. For example, the cosmic microwave background radiation pattern looks uniform everywhere, and large clusters of galaxies are also distributed almost uniformly across space. At least, that's how it used to look, and scientists then turned these observations into basic mathematical rules to simplify scientific descriptions of the universe. But this may have been a mistake. The observations of Adam Rees and other scientists researching accelerated expansion have initially confirmed the isotropic model, at least in part, because the measurements of supernovae have shown consistent results with regard to the rate of expansion. This means that there appears to be some kind of isotropy. However, the expansion is much faster than it should be according to old physical assumptions. It remains exciting in science. In order to understand the puzzle of the new cosmology, we need to take a closer look at dark energy. The exact nature of this energy is still unknown, but its existence and properties are crucial if we want to understand how and why the universe expands in an isotropic way and why researchers came up with the current standard model of cosmology. Dark energy is a hypothetical form of energy that could be present anywhere in the universe and very likely plays a key role in current theories about the expansion of the universe. It's thought to be the driving force behind the accelerated expansion of the universe by acting against gravity, pushing the cosmos apart. In current cosmological theory, dark energy is responsible for about 68% of the total energy content of the universe. Here, you can already see a problem. Scientists blame almost 70% of the energy processes in the universe on an energy whose existence has never been proven. An important element supporting the existence and properties of dark energy up to now was the observation of type Ia supernovae as carried out by Adam Rees and colleagues. The accelerated expansion observed here could not be explained without the effect of a large repulsive force. Further evidence that this mysterious energy really exists was provided by the cosmic microwave background radiation and other large-scale structural studies. However, recent observations by the James Webb Space Telescope have now shaken the concept of dark energy. The JWST can observe the early universe in a level of detail that was previously unattainable. Even the first precise observations revealed structures and objects that are older and more developed than they should be according to the standard model of cosmology. These observations could indicate that the universe may have expanded even faster or originated at an earlier time than previously assumed. All these results indicate that we have not yet understood some crucial elements and forces in the cosmos, including dark matter and dark energy. It's very likely that we are now facing a complete revision of the standard cosmological model, but we are not ready for that at the moment. We can't come up with new theories because we don't have enough tangible information about what's new. Will we find the answer in the world of quarks? The revolution in our worldview will have to wait a little longer. Only when Webb provides us with more images and researchers make even more incredible discoveries will we be able to piece together a new picture. That may take time. In the meantime, researchers around the world are searching for answers that are already available. David Gross is another scientist who welcomes the crisis and sees it as an opportunity. Gross points out that the answers to the great mysteries of the universe are not hidden in the macrocosm but in the microcosm. The renowned theoretical physicist is an expert in the theory of strong interaction and string theory. He is also one of the Nobel Prize winners and received the award in 2004 for the discovery of asymptotic freedom in the theory of strong interaction. The discovery was fundamental to understanding the behavior of quarks, which are the basic building blocks of protons and neutrons. These particles are the main actors in the standard model of particle physics, and they are the basis of everything we can see and measure in space. Consequently, the basic structures and principles of the macrocosm must also have counterparts in the subatomic realms. The concepts that Gross helped to develop deal, among other things, with the events shortly after the Big Bang. Realize that there were no stars and no objects in the universe at that time. For hundreds of thousands of years, there was only an extremely hot primordial soup in which particles floated freely through space without forming bonds. Before the Big Bang, there was presumably only a kind of quantum fluctuation in which all forms cancelled each other out in such a way that, from a physical point of view, they amounted to zero. With the Big Bang, this quantum fluctuation fell apart, and particles packed with charges and forces shot into an otherwise empty space. These particles later became stars, galaxies, planets, and life forms like us humans. Is Gross right when he says that these particles are the answers to all the questions? Probably yes, but how do we study the behavior of particles that were in space 13.8 billion years ago? Among other things, researchers use the cosmic microwave background radiation. This is considered to be a fairly accurate reflection of the events shortly after the Big Bang and has probably not changed much since then. However, quantum physicists and classical physicists do not quite agree on how to interpret this imprint of the early days of the universe. At the moment, the situation in science is that quantum and particle physics cannot be reconciled with traditional cosmology. The findings from the world of formed matter do not fit with quantum physics, or rather, the binding link is missing. David Gross is convinced that this bridge can be found in previously unknown particles and forces. He was one of the researchers who worked hard to reach a consensus between the disciplines even before the debate triggered by James Webb. As co-author of string theory and in a coherent unification of quantum mechanics and general relativity, he was keen to close the gap between the two worlds and disciplines of science. Gross's work on asymptotic freedom describes how quarks behave at very high energies. This is fundamental to understanding the early universe shortly after the Big Bang, when energies were extremely high. His theories can clarify as yet unclear aspects of the expansion of the universe. However, there is some controversy among scientists, as the thesis of string theory is too far-fetched for many classical physicists. David Gross suspects that the answers to all unanswered questions lie in the quantum fluctuations within the microwave background. The CMB fills the entire universe and can be found in all directions around us. The Cosmic Background Explorer satellite, which was active from 1989 to 1993, was the first to notice tiny fluctuations in the temperature of the radiation. From 2001 to 2010, the Wilkinson Microwave Anisotropy Probe researched to find evidence of the Big Bang in these fluctuations, and most recently, the Planck satellite provided one of the most detailed maps of the CMB. However, there is still disagreement among researchers as to how this data should be interpreted. While some claim to have found the necessary evidence for the Big Bang in the CMB, Adam Riess is one of the leading cosmologists of our time. Years ago, the Nobel Prize winner presented groundbreaking work on the expansion of the universe and discovered alarming discrepancies in the measurements of the Hubble constant. These differences from earlier measurements became known as the Hubble tension. Riess, along with thousands of other scientists around the world, eagerly awaited the launch of the James Webb Telescope. The new technology would finally provide proof of the true nature of the universe. Answers to questions such as, were Riess's measurements wrong, or were the older measurements wrong, should finally bring us clarity. Of course, it was also conceivable that the Hubble tension was a previously unexplained phenomenon, but nobody wanted to face that fact at the time. The Webb telescope shocked scientists because the latest measurements confirmed the accuracy of all previous measurements, and thus a pure measurement error could be ruled out. More and more, the differences in the measurement certainly do not occur because our telescopes measure incorrectly. Hubble and Webb each made two measurements, once using Cepheids as standard candles, and once using type Ia supernovae. In this context, standard candles are measurement constants that scientists use to achieve exact measurement results in the universe using the absolute brightness of these phenomena. Actually, both measurement methods should show similar results. What was measured was the expansion of the universe, or rather the rate at which the universe is expanding and how it's accelerating or decelerating in the process. Minor measurement differences would have indicated a difference in the absolute brightness of the standard candle and would have been physically explainable, but the difference is so great that Adam Riess suspects that the Hubble tension is pointing us to other fundamental misunderstandings about the universe. Adam Riess has found the explanation. Did you know that Adam Riess is the father of dark energy? In 2011, Riess shared the Nobel Prize in Physics with Saul Perlmutter and Brian Schmidt. The three scientists were honored for their special discovery that the universe is not only expanding but is doing so at an increasing rate. This realization also shocked the researchers because actually, the universe should be slowing down. Imagine how the Big Bang was an initial energy, and then the universe races off, forming matter and taking up an ever-increasing space. According to our current physics, it should actually slow down at some point. This idea that the universe will eventually run out of steam, so to speak, led to the Big Freeze theory, in which the universe will end up in a kind of state of shock at some point in the distant future. When all energy is used up, all processes come to a halt, and the universe practically freezes. But the measurements taken by Rees and his colleagues showed that the expansion of the universe is not slowing down, it's accelerating. But how can that be? This counterintuitive fact led to the introduction of the concept of dark energy. This force, which no one has yet seen or measured, is thought to be responsible for the mysterious accelerated expansion of the universe. To confirm these theories, the Hubble Space Telescope was used before the launch of the James Webb Telescope. Adam Rees works not only as a professor of astronomy at Johns Hopkins University but also at the Space Telescope Science Institute, which is responsible for the Hubble Space Telescope. The James Webb Telescope confirms Rees's theory. Think for a moment about your view of the cosmos. Do you also imagine a space in which there are objects that rotate, turn, are created and destroyed, and can you perceive that this space is getting bigger and bigger? This is a notion that may seem a bit crazy to us, but it is a fact. The universe shows evidence on many levels of an expansion of the total space it occupies. Until now, the only logical explanation for these effects was that the universe expands from a starting point. But as already mentioned, the universe would then have to slow down at some point, or at least it should not expand faster and faster forever. This is where the James Webb Space Telescope and its unique mission come into play. In the 2 years of operation, NASA's newest telescope has already shown us many phenomena that confirm Rees's theory. These include galaxies that are so old that they shouldn't really exist. Furthermore, so far, there has been no sign of a dark age or of real relics of the Big Bang. Thanks to Webb, we can see clusters of galaxies that are so vast and so large that they challenge the theory of an isotropic universe. All this, together with the phenomenon of the Hubble tension, confirms the assumption that we simply did not understand the universe correctly so far. These new findings will now possibly lead to fundamental changes in science. It is not only Adam Rees who sees that the scientific understanding of the world and the universe is currently facing major challenges. Throughout science, more and more researchers admit that more and more unsolved puzzles in cosmology are forcing us to rethink radical changes in the universe. Who would have thought that a simple telescope could cause our entire cosmology to collapse? Although the James Webb Space Telescope is not just any instrument but the best telescope we humans have ever built, nobody expected these observations. It's as if a completely different universe is suddenly appearing before the researchers' eyes than the one they thought they knew. There are indications that the universe is older than assumed and that galaxies were formed faster and differently than previous theories had predicted. We may even have to get used to the idea that the universe is infinite. Perhaps we don't even come close to understanding how matter really comes into being. James Webb also provides observations that cast doubt on the existence of dark matter. If dark matter does not really exist, another pillar of the old theories will have been lost. But how can we then explain the phenomena that led to the invention of this mysterious matter? It was researchers like Edwin Hubble and Fritz Zwicky who predicted that there must be an invisible form of matter. Only with the help of this form of matter could the incoherent rotational behavior of galaxies and some other phenomena be explained. There are some other approaches to explaining these phenomena without the existence of dark matter, but they are not quite as coherent. Webb also shows us that the assumption that the universe looks the same in all directions could be flawed. This effect of uniformity is what scientists call isotropy. If this isotropy does not exist either, then the old cosmological model is shaken even further. In the early 2000s, Rees and other researchers introduced the concept of dark energy to explain the accelerated expansion of the universe. However, the existence of this form of energy is still unproven, just like the existence of dark matter. Due to these new discoveries, it's expected that the standard model of cosmology will soon be fundamentally revised. But where could this change lead us? These new worldviews amaze us. Imagine we live in a cosmos in which not a single physical constant is correct. That would mean that Einstein's theory of the constant speed of light is not true, that standard candles can never produce the same results, and that physics changes regionally and even over time within our cosmos. Such considerations arose after the latest measurement results of the JWST, and the latest theories go even further. In addition to the idea that our physics can only describe a part or an aspect of the universe, there are approaches that see intelligent forces in dark matter or dark energy. This would mean that our cosmos has something like a soul or its own intelligence, which in turn could explain who created the universe in the first place and why. We would still be a long way from having real answers to our questions after such insights, but if such assumptions were confirmed, we would at least know that there is such a thing as a creator intelligence. Until now, we have always looked into the light and into matter to understand the universe, but now it is becoming apparent that the structures we are looking for prevail in the mysterious darkness of the universe of all places. However, this has not really been proven either, and we will have to continue to observe what is unfolding before our eyes, what measurement results we get from the latest Webb observations, and what that means for our science. We humans have begun to explore our surroundings and, at some point, the universe because we wanted answers to the questions of who or what created it and why it exists. We may now be at a turning point that changes our old worldview so dramatically that it resembles a revolution in knowledge and science. Less daring theories simply state that our universe is much older, or that it may have no beginning and no end. But where do the signs of expansion come from? Here, too, there are exciting new ideas that suggest that our cosmos is subject to regional currents. You can imagine it as something like a wafting bubble formation that contracts or expands regionally, reaching different rates of acceleration and expansion. If there never was a Big Bang, it makes perfect sense. It is hardly surprising that there has been no real evidence for the Big Bang either. Only the fact that for a while all the theories fitted together quite well seemed to confirm the idea of a starting point some 13.8 billion years ago. But we have never seen any real evidence for it. If we take another look at quantum and particle physics, we find further evidence that something is wrong with our old worldview. From the quantum world, we know that our universe must be far more changeable and flexible than previously assumed, and you may be surprised to learn that not a single piece of evidence for the real physical existence of matter has yet been found in particle physics either. The center of the Milky Way, the center of our home galaxy, is referred to as the barycenter. Simplified, this term describes the weighted center of gravity of several masses. The center of the Milky Way lies, from our terrestrial point of view, in the constellation Sagittarius, where it appears to us as a brightly shining structure in the firmament. However, you could say our view is subject to a galactic fallacy. While it's true that the constellation Sagittarius hosts an incomparable number of stars and nebulae, the actual galactic center of the Milky Way remains hidden to our eye. This is due to the fact that the corresponding area is surrounded by dark dust clouds and cannot be observed in the visible light spectrum. This is only possible if we observe the center of the barred spiral galaxy in the infrared, radio wave, or X-ray range. Scientists have speculated for many centuries about what is actually under the dense dust cloud in the center of the Milky Way. The hypothesis that a gigantic black hole exists has been supported over the years by the fact that these massive formations are suspected to exist in practically every bulge of a spiral galaxy. A bulge is a densely populated central region of a spiral galaxy, which literally dwarfs all surrounding areas with its enormous radiation power. What had been a mere conjecture for many decades finally became a certainty, thanks to the data provided by the ESO telescopes. This complex technical equipment observed the center of the Milky Way with special methods, which finally made it possible to observe individual stars in the center of our home galaxy in greater detail than ever before. The main focus of researchers on Earth was the orbital periods and the orbital shapes of the corresponding celestial bodies. The analysis of the obtained data left no doubt that the stars in the central region rotate around a supermassive black hole. This fascinating object probably has 4.3 million solar masses. Sagittarius A*, pronounced Sagittarius A star, the supermassive black hole at the center of the Milky Way, is a source of endless fascination. In detail, this incredible object is located about 26,670 light-years from our home planet. The diameter of its event horizon is a staggering 14 million miles. What made Sagittarius A* so interesting for scientists in the past are the strong radio waves that have always been emitted by the object. This is typical for active galactic nuclei, in other words, those central regions of galaxies that emit unusually large amounts of radiation. As early as the beginning of the 1930s, U.S. physicist Carl Jansky succeeded in locating an amazingly strong radio source in the constellation Sagittarius. However, it was to take more than 40 years before Robert Hanbury Brown and Bruce Ballack discovered Sagittarius A** beyond doubt with the help of the interferometer. The name star was derived from Brown's assumption that the ominous radio source would also excite the surrounding stars to emit radiation. Although this assumption was later proven to be wrong, the original name was retained. The realization that Sagittarius A* is, according to modern research, a supermassive black hole, we owe in turn to Andrea Ghez and Reinhard Genzel. These researchers were awarded the Nobel Prize in Physics in 2020 for their groundbreaking discovery. The enormous galactic forces at work in the center of the Milky Way can also be seen by looking at the behavior patterns of the celestial bodies in the region. Reinhard Genzel's team once discovered that a star with a mass of 15 solar masses was heading for the area around Sagittarius A*. Amazingly, however, the radiating object made an unexpected U-turn when it approached the central region about 11.4 billion miles away. This astonishing effect would later be deciphered as orbital motion around a supermassive black hole. Further investigations revealed that the star, which was named S2, rotates around the black hole at a speed of about 3,100 miles per hour. In the process, S2 needs a good 15 years to completely orbit the structure once. The star S0-102 does the same in just 11.5 years. These two stars are by far not the only ones that regularly orbit the imposing black hole. Today, we know that the star S62 needs only 9.9 years to orbit Sagittarius A** once. The celestial body approaches the structure to a distance of 1.5 billion miles. For comparison, Uranus is separated from our Sun by a distance of about 1.7 billion miles. On its journey through space, S4714 comes even closer to the supermassive black hole. In one particular orbital segment, the star is only 750 million miles away from Sagittarius A*. However, due to the nature of its individual rotational orbit, S4714 still takes 12 years to complete a full circuit. Another impressive spectacle occurred near the black hole in 2013. At that time, the gas cloud G2 was moving towards the fascinating structure. Ultimately, the gigantic gas object, which had 3 times the mass of our blue home planet, approached Sagittarius A** up to about 15 billion miles. What happened then gives us an authentic impression of the elemental forces that rage in the vicinity of black holes. According to researchers, the huge gas cloud was completely torn apart due to the forces acting on it. At the same time, the ultraviolet radiation of the surrounding stars caused G2 to be brightly illuminated. If one follows the findings of the scientists, Sagittarius A* is not the only black hole that exists in the central region of the Milky Way. In early 2005, for example, experts succeeded in observing regular bursts of brightness in the immediate vicinity of Sagittarius A*. The information obtained with the help of the Chandra X-ray Observatory in turn suggests that the areas around the central black hole are adorned by countless other such fascinating objects. Specifically, up to 20,000 black holes are said to rotate within a radius of about 70 light-years around Sagittarius A*. Another scientific investigation ultimately brought an incredible idea into the center of scientific interest, the dark matter core. The new scientific thesis currently circulating through the ranks of experts could render the hypothesis of a supermassive black hole at the center of our home galaxy completely null and void. Because as a result of recent observations, some experts have arrived at the assumption that the center of the Milky Way could accommodate, in truth, not a black hole but a gigantic core of dark matter. The background for this thesis lies in the behavior pattern of some unusual galactic objects, which are classified by experts in the so-called G-class. These are comparatively compact, almost star-like structures, which, however, assume the form of an interstellar cloud as soon as they approach Sagittarius A** at a certain distance. To explain the strange motions of the enigmatic objects, a groundbreaking theory has been proposed that Sagittarius A** might actually be a collection of spatial dark matter called darkos. And indeed, the models that accounted for such a dark matter core were expected to explain events around the center of the Milky Way more comprehensively than those models that included a supermassive black hole. Dark matter, by the way, is a postulated form of matter, but its existence has not yet been proven beyond doubt. Dark matter helps, however, to reconstruct the rotational movements of visible matter. The ratio of dark matter to visible matter is thought to be 5:1. The name dark is somewhat misleading, however, this moniker comes from the fact that this special form of matter does not possess interaction with light rays. It, therefore, does not appear to us as a visible dark structure. Researchers assume, though, that dark matter interacts with gravity. Furthermore, it's conceivable that overdense accumulations of dark matter can occur in the universe, which in turn could give rise to dark matter nuclei. According to some suppositions, exactly this could be the case in the center of the Milky Way. This assumption throws the currently widespread thesis completely into chaos. The Milky Way is known to host thousands and thousands of sparkling celestial objects. Faced with the approximately 400 billion stars estimated to reside in our home galaxy, we quickly fall into a struck wonder. However, not every luminous structure in the Milky Way can be immediately placed in a known scientific context. The experts are also aware of this fact, which is why they are vigorously trying to decipher the mysterious glow at the center of our local barred spiral galaxy. Experts agree that there is a supermassive black hole in the galactic center of the Milky Way, which experts have named Sagittarius A*. However, in that central region, scientists also located a high-energy gamma-ray glow, which experts refer to as the GeV excess of the galactic center. For many years, astronomers have been trying to fathom the background of this enthralling phenomenon. One of the most exciting and hotly debated explanations is that the mysterious gamma glow could be produced as a result of the annihilation of dark matter. However, research published a few months ago by a team of astrophysicists may now put an end to this controversial theory. Within their work, the scientists created a simulation model, which dealt with the gamma burst in the center of the Milky Way. The experts came to the conclusion that the annihilation of dark matter as the cause of the ominous glow can be practically ruled out. Probably the largest problem that arises with investigations of this kind is the fact that the existence of dark matter has yet to be proven beyond a doubt. Within the ranks of scientists, it's rather a postulated form of matter with the help of which movements of visible matter can be explained. However, the study results published by the University of California astrophysics team now shake this theory to its core. The gamma-ray glow, the GeV excess of the galactic center, was first detected when the Fermi Gamma-ray Space Telescope began taking a closer look at the corresponding central region of the Milky Way more than a decade ago. It was during these scientific surveys that researchers finally noticed the mysterious gamma-ray glow. Gamma rays are the most energetic electromagnetic waves in the entire universe. The rays are generated mainly by impressive celestial bodies. These include so-called millisecond pulsars. These rapidly rotating neutron stars owe their name to the fact that their rotation time is less than 20 milliseconds. But also colliding neutron stars, supernovae, and black holes have been identified as sources of gamma rays in the past. However, when experts evaluated the data provided by NASA's Fermi telescope, they were unable to pinpoint the source of these high-energy lights. If we look at the statements of the Italian nuclear physicist Mattia Di Mauro, we realize how much scientists disagree about this controversial question. According to the analysis of the Italian, the source of the GeV excess is, contrary to the Californian research results, due to interactions with dark matter. As already mentioned, however, it is not possible for us at present to prove the existence of this postulated form of matter directly. All that suggests its existence are gravitational effects which cannot be explained by the influence of visible matter. For example, galaxies rotate significantly faster than they should be able to from a purely factual material point of view. Therefore, scientists are firmly convinced that the vastness of the universe is permeated by an undefined form of matter that causes the otherwise inexplicable gravitational effects. Although we cannot see dark matter or detect it by any other means, it is believed to make up about 80% of the total matter in the universe. The scientists Lisa Goodenough and Dan Hooper put forward the thesis that certain weakly interacting dark matter particles could collide with their antiparticles, effectively annihilating each other. This process should lead, among other things, to the fact that gamma rays are sent into the widths of the universe. As is the case with any unsolved scientific question, this is not the only thesis experts have advanced to try to explain the gamma glow in the center of the Milky Way. About 3 years ago, another team of researchers concluded that it's primarily the influence of undiscovered pulsars that causes the galactic phenomena in our home galaxy. The fact that we have not yet seen the corresponding old dead stars is simply due to the fact that they have so far successfully eluded our terrestrial gaze in the crowded, dusty center of the Milky Way. However, recent investigations have revealed that the distribution of the GeV excess in the central region of the Milky Way is not uniform. This is strange, for if the annihilation of dark matter particles is indeed responsible for the gamma-ray glow, a uniform expression would be very likely. In fact, however, the gamma-ray emissions present themselves in a simplified speckled form. Many experts attribute this to the fact that the GeV excess would have solid point sources, like pulsars. It didn't take long, however, before this scientific thesis was also challenged. Another team of scientists came on the scene, defending the thesis that the gamma-ray glow, despite its speckled distribution, could be produced by dark matter. However, the subsequent theoretical models created by other experts, which looked at the galactic center along with the hypothetical dark matter annihilation, painted a different picture. According to them, it is unlikely that the collision of dark matter particles and their consequent annihilation are the cause of the GeV excess. Does it mean, in the reverse conclusion, that this controversially discussed thesis was finally banished from the ranks of scientists? In fact, that's not the case. The Italian nuclear physicist Mattia Di Mauro refers above all to the extensive data set of the Fermi telescope, which the researcher uses within his studies. The scientist looks at its information that was collected over a representative period of more than 10 years. Specifically, the Italian compares the information collected by the Fermi telescope with the astronomical anomalies recorded by the Pamela detector. This was a technical module that had the task of studying cosmic rays. The complex device, which was attached to a satellite orbiting the Earth, was in service between 2006 and 2016. Di Mauro also includes the results of measurements taken by the alpha magnetic spectrometer on board the Space Shuttle and the ISS. If the excess of gamma rays were due to the interaction between cosmic rays and atoms, the spatial distribution of gamma rays would be directly related to the prevailing energies, Di Mauro said. Accordingly, there would be a larger spatial distribution at lower energies, while the spread should be much smaller at higher energies. However, the study by the Italian nuclear physicist shows that the spatial distribution of gamma excess is not related to energy. Moreover, such a circumstance has never been observed before in the universe, which makes the thesis that it's triggered by the interactions of dark matter more than ever the focus of scientific interest. In fact, most researchers currently assume that all dark matter particles have similar energies among themselves. The finding that the excess of gamma rays is unusually concentrated in the center of the Milky Way fuels the hypothesis that dark matter actually contains a completely new type of particle. What this particle form is like, however, is still literally written in the stars. To approach this highly intriguing question, Di Mauro, in collaboration with his Swedish colleague Wolfgang Winkler, searched for gamma-ray excesses in nearby spherical dwarf galaxies. However, the galactic search of the two renowned researchers was not met with success. If one follows the statements of D. Morrow, this circumstance does not mean at all that their thesis is incorrect. According to them, the research results would help rather to further limit the potential mass of dark matter particles. As you notice, the current state of knowledge about the true origins of the gamma glow still seems extremely diffuse. We can neither prove that dark matter influences are responsible for this fascinating phenomenon nor that they are not. It will probably take several more years and much more research to get to the bottom of this cosmic mystery once and for all. Until then, we wait spellbound for new realizations scientists will come upon concerning this topic in the future. It is October 19, 2017, when an absolute milestone is added to the list of astronomical discoveries. With the help of the Pan-STARRS telescope in Hawaii, researchers managed for the first time in history to identify an object within our native solar system that was classified as interstellar. As the name suggests, interstellar objects are astronomical entities that originate in interstellar space and are not gravitationally bound to a central star. However, this term is also used for those objects which are on an interstellar trajectory but temporarily pass into the immediate vicinity of a star. This was also the case with the exciting body discovered in Hawaii, which was to receive the official designation Oumuamua. However, by the time the object was added to the star charts, it had already passed our Sun and was already on its way back into interstellar space. The first investigation of the orbital properties initially suggested that Oumuamua would be an ordinary comet. However, this assumption was soon overshadowed by big question marks because, actually, with a closer look, the structure possessed no comet-typical tail. But this would not remain the only riddle to follow this exciting discovery. First, the experts had to take a closer look at the trajectory of this exciting object and reconstruct its possible origin. What was certain was that Oumuamua plunged into the solar system almost perpendicular to the orbital planes of the planets. Then, in early September 2017, the body had passed the ecliptic plane, the apparent orbit that the Sun traces in the sky. Using this information, experts were able to calculate that Oumuamua had bumped towards us from the direction of the constellation Lyra, not far from the main star Vega. The object finally reached its observed maximum velocity on September 9, when it passed through the apex of its orbit at a speed of more than 45 miles per second, approaching within 23 million miles of the Sun. A little over a month later, Oumuamua made close contact with our blue home planet. The closest distance between the object and us was about 14 million miles, which is about 60 times the distance between the Moon and Earth. But then it was time for the exciting object to take its leave. With gradually decreasing speed, Oumuamua took course in the direction of the constellation Pegasus so that it is currently moving further and further away from our home solar system. But already, the analysis of the trajectory caused raised eyebrows among the ranks of experts. The deceleration the structure ran through on its flight in the direction of the Sun was somewhat smaller than it would have been under the influence of gravity alone. One theory tried to explain the additional acceleration with the outgassing of volatile materials. However, this process would most likely have set in motion an enormous effect on the body's rotation, but no such change could be detected. In order to determine what Oumuamua was actually about, the ominous structure was viewed by several modern telescopes. The unusually intense brightness fluctuations that were registered in the course of this suggested that the object had a cigar-like shape. However, the extreme brightness changes could not be explained by the rotation period of the body. Consequently, it seemed that Oumuamua is not rotating around one of its axes but literally tumbling through space. The fact that no dust particles were found in the immediate vicinity of the body led the scientists to the conclusion that the mysterious body does not contain water and is probably composed mainly of rock or metal. Assuming that Oumuamua has become exceedingly dark as a result of unchecked bombardment with cosmic rays over millions of years, scientists suspect a very low albedo. Specifically, the albedo is estimated at a value of 0.04. However, this is only a theoretical number that has not been directly proven. If the assumed albedo is correct, Oumuamua would have an average diameter of about 600 feet. What the experts do know, however, is that the surface of the structure has a reddish tinge, which is attributed to the existence of organic matter. After Oumuamua was categorized as an asteroid a few days after its discovery, it's now again considered more likely that it's a comet after all. But these are still by far not all the theses proposed in the field. Some researchers pursued the approach that the body could be composed of frozen hydrogen, an exciting theory which turned out improbable due to further investigations. The possibility that Oumuamua could represent, in truth, a stick material ice fragment of a distant planet is discussed likewise in the ranks of experts. Equally, the most exciting as well as most controversial explanation approach departs from the idea that the mysterious structure is not at all a natural body but the work of an advanced extraterrestrial species. The unusual cigar-shaped form of Oumuamua alone fed the first speculations that it could actually be an extraterrestrial spaceship. This theory was then further fueled by the thoughts theoretical physicist Avi Loeb and Shmuel Bialy brought into the field. The two researchers came in the course of their work to the conclusion that the registered orbit deviation, which could not be explained by gravity, as well as the missing dust development, agree very well with the assumed characteristics of a very thin structure pushed by the radiation pressure of our host star from its course. Consequently, it would be conceivable that the corresponding structure in truth embodies a complex solar sail which was sent on its way into space by an extraterrestrial civilization. The rest of the expert world also became aware of this exciting thesis that Oumuamua was artificially created. To get to the bottom of this exciting hypothesis, the radio telescope at the Green Bank Observatory in West Virginia was pointed directly at the interstellar visitor. Through this endeavor, scientists hoped to possibly obtain signals that would indeed suggest an artificial origin for the object. Although it was considered exceedingly unlikely in advance that artificially generated signals from an extraterrestrial species would be found, the researchers saw their work as a worthwhile and unique opportunity. So, Oumuamua was studied in detail over a period of 14 days. The evaluation of the collected data finally delivered the sobering realization that no signals were found that would point to an artificial background. In order to uncover the identity of this cosmic mystery, the experts are currently playing with the idea of simply turning the galactic tables. Now that Oumuamua has moved close to our blue home planet, it is now time for us to pay the entity a visit. However, it's anything but easy for spacecraft of our time to intercept Oumuamua. For example, the hyperbolic excess velocity of the object is given at about 16 miles per second. By comparison, Voyager 1, the spacecraft with the highest current hyperbolic excess velocity, reaches only 10 miles per second. However, a sophisticated maneuver could still make it possible for us to reach this structure one day. The ignition of a solid fuel engine would literally shoot the probe out of the solar system. In this way, it would be possible to reach Oumuamua about 16 years after the launch of the spacecraft. However, the experts' ideas are still far from being put into practice. So when and if we will get to the bottom of the Oumuamua mystery is still literally written in the stars. Now we want your opinion. What do you think about the exciting interstellar visitor? When we turn our gaze to the firmament on starry nights, we can see for ourselves the overwhelming diversity of the universe. In view of the innumerable stars that sparkle at us from high above, we realize time and again how small we are in the overall context of the overwhelming cosmos. At the same time, however, it's also true that what we can see from our earthly vantage point by no means reflects the true dimensions of the universe. In fact, our view of the stars is limited by some natural factors. Those areas of the cosmos we can see from our Earth are defined within cosmology as the observable universe. Based on the assumption that the universe is isotropic and homogeneous, which means that it always presents itself to the observer in the same way independent of his location and direction of observation, a diagram results which explains this standard model comprehensibly. So we can imagine the observable universe as a sphere whose center forms our blue home planet. The spherical range surrounding the Earth includes all those areas visible from our point of view. In principle, the borders of this sphere are fixed by the information which can have reached us since the birth of the universe. In view of the fact that the Big Bang occurred about 13.8 billion years ago, one could assume that this number also corresponds to our terrestrial observation horizon. However, this is not the case. In accordance with the Big Bang Standard Model, the corresponding value is actually given as 46.6 billion light-years. It's important to note that the universe is by no means a rigid construct but that it's constantly expanding. As a result of this cosmic expansion, the light from the observation horizon has also moved further and further towards our earthly home. Expressed in other words, this means that previously covered distances were extended subsequently. To further illustrate, those formations which appear the most distant within the observable universe for us lay in the time in which they emitted the light we perceive today, 40 million light-years away from us today. However, there is a gap of 46.6 billion light-years between us and those remote objects. Also, the redshift, the cosmic background radiation, and the so-called Hubble radius indicate which cosmic regions we can detect from our Earth. The event horizon, in turn, determines the maximum distance that a structure may currently be from us so that its light can just reach us in a theoretical limit in the infinite future. Considering this background information, we become aware that the nightly firmament is always equivalent to an optical time travel. All the sparkling formations in the night sky are therefore only snapshots of how the glistening bright celestial bodies looked in the past. If something exists beyond the boundary of the observable universe that we cannot see, this means that these objects are so far away from us that the light emitted by them has not yet had enough time to reach us. The exciting question is, therefore, does something exist out there that has always been hiding from our prying eyes? And if so, what could it be beyond the border? Well, it's obvious that these questions are anything but easy to answer. In order to get an overview of whether there is something out there that we can't see, we also have to take into account the curvature of the observable universe. For in fact, experts cannot say with absolute certainty how the cosmos is actually structured.